In this video, we're going to try to get more practice constructing Lewis diagrams, and we're going to try to do that for a cyanide anion. So this is interesting. This is the first time we're constructing a Lewis diagram for an ion. So pause this video and see if you can have a go at that. All right, now let's do this together. So we've already seen in many videos, the first step is to essentially count the total valence electrons that we're dealing with. And the reason why we do that is to make sure that we're allocating all the valence electrons. To help us there, we can look at a periodic table of elements. You might already know that carbon has 1, 2, 3, 4 valence electrons in that second shell. It's in the second period. So you have 4 valence electrons from carbon. Nitrogen has 1, 2, 3, 4, 5 valence electrons in its second shell. It's in that second period. And so the valence electrons from a neutral carbon and a neutral nitrogen-free atom would be a total of 9 valence electrons. But we are not done yet because this is not a neutral molecule. We have a negative charge here. It is an anion. It has a -1 charge. And so because of that -1, we can think about it having an extra valence electron. So let's add a valence electron here. Why did we do it? Because of this negative charge. So we're dealing with a total of 10 valence electrons. Now the next step is to try to draw single bonds. Try single bonds and identify a central atom. Now we only have 2 atoms here, so really neither feels central. So let me just put a carbon and a nitrogen next to each other here. And then let me draw one single bond. So by drawing that one single bond, I have now accounted for 2 valence electrons. So now I am left with 8 valence electrons. And so that's the next step. Allocate remaining valence electrons. Allocate valence electrons. So let me start with the more electronegative. Let's try to get nitrogen to 8. Already has 2. So let's give it 3 more lone pairs. So we have 2, 4, 6, 8. So I have just used up 6 of these remaining valence electrons, so minus 6. So I have 2 left to allocate. So let me give carbon 2 valence electrons, like that. And there I have used up all of my valence electrons. Now let's see how happy everyone is. Nitrogen has 8 valence electrons hanging around, 2, 4, 6, 8. But carbon only has 4. 2 and 4. So this is where we think about whether we want to have some extra bonds or higher order bonds. So how can we give carbon more valence electrons? Well, what we could do is we could take some of these lone pairs around nitrogen and then use them to turn this single covalent bond into a higher order bond. So let's see, if we were to take these 2 and turn it into another covalent bond, what is going to happen? Let me erase all of these, and then I'll just draw another covalent bond. So nitrogen still has 8 electrons hanging around. Carbon now has 6, so maybe we can do that again. So let me erase these 2 characters. Let me erase these 2 characters and make another covalent bond out of them. So let me make a covalent bond out of them. And so now what's going on? Carbon has 2, 4, 6, 8 valence electrons hanging around. Nitrogen has 2, 4, 6, 8 valence electrons hanging around. So this is looking pretty good. But are we done yet? The simple answer is no. We still haven't represented this negative charge in our Lewis diagram. The way that we would do that is say, hey, this entire molecule, you put brackets around it, has a negative charge. And now we're done. We've allocated all of our valence electrons. We have our octet rule on all of our atoms that are not hydrogen. There's no hydrogen here. And we're showing that this indeed is an anion. And now we are done.